Okay, this is another video. This is the first of Shooting Minibadges. Did talk to the creator of this mini badge, Cyberm3n, and let me go through it. Kind of explain some of the challenges. This is his remake of the mini badge that had an issue before the con. Wasn't fully able to get through, so simplified it just to be the LEDs. This is the problem one that I've already gone through and mitigated. First, we thought it would be his 555 timer. It was set up a little bit differently. But later, review and analysis noticed that the 4017 chip wasn't quite wired correctly. A few caveats here I'll talk over as I'll look at another one that had similar issues. These ones could be plugged in. They wouldn't really work. They just kind of sit there. Some would get hot. Some modifications would cause the chip to smoke. The chip that smoked most likely was the 4017 here. We can bypass the 555 timing and go off of the clock of the mini badge as shown here. This one is going to be a little bit easier to get to the clock as it is connected to other lights and transistors to go about. It looks like this has a comparator between clocks. Kind of a fun aspect here. Don't quite have all the parts to do the 555 timing, but we'll go through some of the issues here. One of my first things that I like to do when problem shooting is get out a multimeter. Any multimeter that does the beep aspect is key. You want to get it in there, get into the continuity beep mode, do some tracing. Don't really need to have you see the face of this as it goes through, just be able to watch the chords. So pin 1 here, that is used for some aspects, but the big ones to look at is this pin 8 and 16 are the power pins. And right now, this pin 8 is tied to the 5 volts. And then this pin 16 here is tied to, I don't know if he has ground everywhere, but it's tied to ground. And if you look at the data sheet for this, this one is VCC, and this one's VDD. That can get a little confusing at times when looking at. VCC is actually voltage negative, like sink source, and then VDD is your voltage positive there. So this one should be tied to the 5 volts, and this one should be tied to the ground. So in order to fix this, we'll have to cut the trace or do some other modifications. On the back here, it's not bad to cut the trace. It's similar to the issue here, cut the traces, and then soldered it on, and then soldered some Bodge wire to make it work. So to cut a trace, get a nice sharp X-Acto knife, sharp cutting tool. And I like to cut it right by the pad. Without much copper pour, this is a fairly easy thing to do here. Try not to cut other traces. You just can put some pressure down and slightly just cut. And do this a few times until you fully separate and sever that trace. It's really good to do this on the back. After a little bit, you can then check to see if you fully severed it. I print back on. and testing. You see that trace is still not cut fully. Let's make sure it's not tied to anything else nearby. That's touching the leads itself. Okay, so getting in there, still has some aspects. Okay. I think I was able to fully get through that trace now. Feels like it's on board. Let's double check. Okay. Now it's fully severed. Don't make sure. If I touch there, it should be, but here it's not. Okay. Now this other one, this board is a little bit harder. It has a via right on the pad here. If you flip it over, see the trace goes up. It's on the front of the board. It does make this a little bit harder if you want it to have it look nice to remove that trace. The other option is that I don't solder that on and lift that pad up instead of soldering it down. This one I was able to cut the trace. As you can see here, it was cut there, and then this one was actually cut on underneath the chip on the other, and then rerouted. It's a little bit cleaner here since the front art prevented doing vias and a lot of work on the top here. So with this, I cut it at the pad up here, just to be safe. It might look a little bad, or you can cut it right by the via. Or you don't solder that pin on. Ideally you want to cover that then, so you don't accidentally solder onto that part and then cause a short within the chip, and it won't work. So I'll try to do this the most precise I can. Just up here by the pad. The issue of doing it really close to the pad is that you might accidentally bridge it when you solder. That pad on, because I'll have to solder there. So I want to make sure it's good. Just give you some ideas of how this goes. These are pre-production prototypes. So the ones that actually went into SaintCon end up being simpler ones. As we weren't able to do a full analysis of these mini badges before the conference. Really cool designs, great throughput. This can get you really thinking on everything. Pull up the spec sheets on your ICs as you go through them. Make sure you're following them. Follow the guides. Go look online for other examples of people using the same chips. This is a really fun chip. I've used the 4017 before myself. So now I think I got it. Cut. So it sounds like I got it fully connected. You can see the little bit of blemish there by the pad. Okay. I'm looking through the other key parts is so 16, 15, 14. I believe 14. Where's it 15? Oh, let's see. Make sure you're in the right orientation. So 15 here is reconnected down. That's fine. 14 should be going to 3 here because that's a clock. The other one to watch out is this 13. It's actually a reverse trigger. So right now it is floating and that will cause you issues. You should connect it to ground as well. So that'll be another aspect into it. As you can tell here, this one's also tied to ground. It's a little bit hard to see and everything. So this went to the clock to then feed this one the clock, and then this one went to the ground here on the side with this green wire. I should use black to keep the grounds all similar and the same. And then the yellow went to power and green is clock. Kind of the aspects there. So let's recreate it here and get this going. So I like to use some low gauge wire. I like having a multi-pack, really thin. This is between 30 and 24 gauge. I actually forget what it is. I think it's somewhere in that range. I think more in the 26 through 30 aspect. But now that we've done the analysis, be able to retrace the circuit, see what's up with it, we can do some soldering and get it up and going. So for that, okay, got my soldering iron set up, get some tweezers. I have some parts. I think this is enough parts to get it going. Let's prep the headers. Be careful, they do fly. Luckily I only need 3 sets of 2s. Get your solder together. I like Kestra. This MG chemical is not too bad. The Kestra is still my favorite. It's the best I've used so far. If you can find it for a good deal, it's worth the purchase. I'll have to do a review of the different solders that I use a little bit later. Just can't go through it. I have 3 different types of Kestra. I have 1 MG chemical and 1 other no brand ones, just to kind of give you analysis of different aspects. So I like to always start usually with pin 1 here. These are really small LEDs, so actually I want to probably start with these LEDs that are round, and then don't quite have the resistors and other aspects. I'll have to follow on with this fully running for you. For now, I'm thankful that Cyberm3n is allowing me to do this video and talk about some of the pitfalls of the process. Everyone makes mistakes into it. Reading the chips, especially your first time dealing with chips that label their ground and power a little bit differently. That's good. Great designs. He's really creative in this work. Using both clock, having two different clock cycles in here, using the 555, playing with new circuits that sometimes you aren't that familiar with. Biggest advice I have is that you look through the spec sheet really closely and watch it as you go through. As I said, do be careful soldering where you cut traces, as you can accidentally bridge them. I'm just gently praying on that for right now. These are all diodes. So orientation, not that familiar with. I have to look this up. As they are pretty small. You have a solid line on one side. I can't remember if that completes it or not, so I'll take a second. I'll have to look those up. I don't have any LEDs for this for right now. Transistors are a little bit easier. Quite a few of these. Let's get them on. And then I'll have to go look at the orientation. A nice dense board. Lots of soldering. Okay. I just want to put most of these on before I do the bodge wire aspect. That covers a lot of area and space on the chips on the board, so it makes putting these chips on a little bit harder. Okay. Okay, looking up, these are high switching diodes. There's a straight line on them. The line does go into ground. That's what it looks like. So that's your cathode side. Looks like this runs RGB LEDs. They're on the sides. Really cool aspect here. These are really tight fitting. So this is going to be really close work here. I might want to use my caster. So I'm already starting to bridge. MG, I think it only has 2% flux. I like to run with 3.3% flux wire most of the time. This runs a little bit nicer, easier to flow. As you can see, this is much easier to solder with. Let's do up. Do some bridges here. I'll have to come back and fix. So always keep your solder sucker. I really like this engineering one with the silicon tip here. Does a great job. Just clearing out the extra solder. Okay. Then let's go through and make sure where you sucked. Still have a little bit of solder. Pins are still connected. Okay. Let me go through and get all these. Little things on, at least around the chip. And we'll get to some Bodge wire. Assembly. Probably should use because I want the circuit as complete as possible before we're good. Thin tweezers, very useful, very practical. I'm not quite sure why he's using so many of these fast switch diodes. hardest thing is making sure that you get your orientation right. When I get the rest of the parts, I'll do video 2 of this series and show this badge fully working how it's supposed to. I'll try to put together the non-complex one as well for comparison. So these should be going to ground on that side. Looks like I have one more, and then the row over there. Do the row over there a little bit later, as it won't interfere with the wires as much. I do wish I had the RGB LED. I think I have the right one available right now for it. Okay. Now let's go through and finish sliding these together just very lightly. Tap them. Don't need much solder. The biggest thing is that you connect it down to the pad. Keep the little spikes up. Tighten to my iron. Oop. Doesn't look like I fully soldered that one on. Okay. Okay, I believe I got all these. Should all be connected now. Let's go through the transistors. Make sure these ones are as well. Such small parts, I like to make sure you clean the tip a little bit more often. I think these other ones won't be too bad to install even after. Okay. I think that's all set. I'll do it 2 ways. With this one, I'm just gonna tie it with the clock to make sure the cycle's right. Let's make sure I didn't mess up. That should still be disconnected. And that one should still be disconnected. Okay. And then also with the diodes, you can set this in diode mode if you weren't sure, and you can test your diodes. sure. Oh, there we go. So you put them backwards, they won't show anything. I guess here. So you can see this aspect, hopefully. Sorry for the big cable mess. Okay, so let me get this green. Put this board up here. Turn this opposite, it will sit and not give anything. Turn it on right, you'll get the voltage drop it provides. If you go here, should be about a half a volt. Give a verification there. So it all looks good. The parts look good. Let's solder in. Okay. The upside ones that like to tie in that first corner. Let's get it on, press down, get some good heat. Get it good. Hershey's Kiss. So since I cut this one, I want to not solder too much around it. Make sure it's there. Doesn't take long, just a little bit of time. Get nice, good solder joints. Okay. Now, let's get into our Bodge wires. So here you want to have like a pair of strippers and wire cutters. So that one's ground, that one should be power. So I want to cut there. It's going to go into the 5-volt pin here. The 5-volt is not really connected anywhere else on the circuit, so we'll tie it right into the other side, because I should do blue. I'm going to go around it, and I probably should solder on those diodes because they're going to get in the way. So let's just go through and finish. Finish doing these. It's always good. 4, 5. Oh. Try not to lose any in the process. Zoom a little bit back in. Zoom even more in. I want to make sure get my orientation right. On this. I probably should have done this before I prime the header. It is a very tight fit on that first one. Okay. It's a lot more complex of a circuit. Always backwards. Okay. Okay. Going through and making sure those are all soldered on. Okay. Let's get back into our Bodge wire. I like to kind of pre-determine its length, round. Up. Okay, when you strip the wires, you want to strip just a little bit off both ends. I like to do a little bit more on the end. It's going to the pad and looking at the chips here. That one is going to the power. So with that, I like to just add a little bit of solder to the top of my iron. Good. So it's really good. Off the other one. Okay. And that I like to bend slightly the wire to kind of fit the trace here. So there will be soldering on LED a little bit later. I want to try to make it install on the side here. Get that on. Barely on. Okay. Where the third hand is a little bit useful as well. There we go. Get a good connection. That looks much better. And let's route it up. And this one's a little long, which is okay. If you want it tight, you can do it a little bit differently. I'll leave a little bit, cut it. And let's solder it onto that pin. You can do this on the bottom side as well. It'll be fine. But due to being a primary power pin, I don't want to risk it. Okay. So that now should be connected. Looking at it, that's pin 16. Pin 16 should go to VDD. Okay. Now let's work on the ground pin. This is where we can get out our meter again. See if there's a different ground on the board somewhere that we can tie into. Perfect. So there's that one, that one, that one, these should all be into a ground as well. Okay, so it looks like I can go on. C2. Well, the C1 goes to ground. So we will ground there. When we get C1, we can a little bit of soldering that point. So this won't take much. Cable. Just a little bit. Sorry. A little bit of cable. Okay. Doesn't take much. For these ones. Get a little bit of solder on. Get some tweezers. In place. Solder it on. Okay. Should be good. And now we can just bend this. To fit on the ground. Eventually we'll assemble it onto that capacitor. For now, watch your heat. Casing does shrink fast. Okay, and then the other one that we have to do is, if you remember, that pin that's floating, pin 13 here, needs to be tied to ground as well. So that'll just go up and over the chip. Fairly straightforward. Modification. With that, I like to start on the side with the wire right there. So hopefully it secures quickly. Make sure your tip is clean. And we need to count up to 13 here. Oh, did not get secured. Might be a slight issue. I don't want to. Okay, I think that's on now. Okay. Now we can bend this around in good shape for an easy install on that pin 13 there. Dab. Dab of solder onto it. Get it in place. There we go. Bridge. Okay. Let's double check all our work. Get your multimeter, make sure get back in continuity. And now we can go here. Okay, it's grounded. It's grounded. That's not power. It's still not grounded. And this one's still not on that. The other thing I would like to do is make sure the grounds are together. But I'll work on that one a little bit later. But for now, that gets the 4017 chip online. No LEDs yet. We can play it into a board. Ideally, I would have a breadboard available to plug it into. I mean, test it. We can make sure the chip's not getting hot. No hot parts, so that's a good sign. Still a bit to do to put it fully together, but that is how to reroute a misconfigured 4017 chip. Part 2, I'll get through and make everything else for you. Thanks.